We have already discussed on the Euler's formula for polyhedra. Now we are discussing for Euler's formula for graph, which is a part of SSLC 10th standard mathematics last chapter. It's polyhedra and network. Euler's formula for graph is n plus r is equal to a plus 2, where n is node, r is region and a is arc. Let's try to understand what is NRA. In the figure above, the dots represent n is equal to nodes. We have here 6 dots, 3 here and 3 here. Therefore, we say n is equal to 6. And arcs are the lines which are connecting these dots. We have 3 in this triangle over here and 3 in this triangle over here and 1 in middle over here. That's why we say arc is equal to 7. And region is the portion which is bound in between the arcs, which is enclosed in the arcs. 1 is here and 2 is here, and 3 being the infinite region which is outside this. Now let's go back to a textbook and understand some definitions. To read them properly, you can just pause the page over here and then we'll go ahead. Using the formula n plus r is equal to a plus 2, we will now solve the exercise sum 10.2 in the textbook. Here you can easily understand that n is equal to 3 here because we have 3 nodes A and B and C, and the number of arcs are 4, 1 here and 2 here and 3, and this is fourth one. Region is one region B which is inside this, second region which is inside this, and one is the infinite region. So it is 3. Hence we say n plus r is equal to a plus 2, which is 3 plus 3 is equal to 4 plus 2, which is 6 is equal to 6, and is verified. In the similar way, all these remaining problems can be done. For any doubts, you can always email me. My email ID is pawanpawan@teachers.org, teachers.org, or call me on 9449065 9449065 or pawan@teachers.org. All these sums are very clear and they're not very tough to understand. Still, you can always call me for doubts. The next topic on this chapter is traversable graphs. That means if in case we try drawing a line with the help of a pencil without lifting it, if we're able to draw a shape, then that's called as traversable. Traversable means going both the ways. We can go this way all around or go from here and go back over there. That's the meaning of traversable. So to understand this more better, we'll solve some things in the textbook. Before that, understand that a graph is traversable only if in case it has 2 odd nodes or has only even nodes. Either should have 2 odd nodes or should have only even nodes. The order of a node is the number of paths starting from it or reaching it. Let's go back to textbook and fill the data in the textbook. See, in this figure over here we have 3 lines starting from A and 3 lines reaching B. Hence the order of A and B is 3. This figure is traversable because it has only 2 odd nodes. Remember, a figure is traversable only if it has 2 odd nodes or it has all even nodes. In this figure, A, we have 2 lines going this and this side, that is 2 nodes, and B is also 3, C is 2, D is 2, E is again 3, F is 2. This is not traversable because it has 2 odd nodes plus 4 even nodes. Here in this figure also we have 4 odd nodes, more than 2 odd nodes. This figure is not traversable. In this figure we have all even nodes. Understand this, it has all even nodes. A is 4, that is we can go from this point and come round again, that's 1, and then go in 3 directions. Similarly, B also can go from here and come back and come back like this, that's 2, and go like this and go like this, therefore it is 4. C also we can either go like this or come back like this, so that becomes 2 arcs, and then travel in this direction or this direction, so it becomes 4. In this figure we have all even nodes, hence this figure is traversable. This figure, it has all even nodes again, so it's traversable. This figure has all odd nodes but more than 2 odd nodes, hence it is not traversable. With the explanations given till now, exercise 10.3 can be solved easily. Still, if in case you have any doubts, you can always email me. It is pawan@teachers.org, or call me on 94490 The next topic is matrix of a graph. To understand this, let's go back to textbook again. In this figure, as we see, it has 3 lines traveling from here, or you can call it the 3 arcs from A to B, and from there's no arc connecting from A to C. Again from B we have again 3 arcs traveling towards A and 2 of them traveling towards C. From C we have 2 arcs traveling towards B but no arc traveling towards A. This information can be tabulated in the box as follows. From A to A we have no arcs, so it is 0 over here. From A to B we have 3 arcs. A to C no arcs, so 0 again. B to A is 3 arcs. B to B is 0 arcs. B to C is 2 arcs. And C to A is 0, C to B is 2, and C to C is again 0. In this way, this can be mentioned in the form of matrix as shown over here. Based on this information, you can consider the matrix for each of the following networks very easily. Still, if any doubts, you can always call me or email me. Now let's do the reverse process, that is constructing a graph from a given matrix. The graph is constructed, this graph is constructed from this matrix. Here you can see that this graph is first tabulated in this format, wherein we put A, B and C here, and similarly A, B and C here, and just copy the matrix here in this box. That means A to A there is no arc, A to B is 1 arc, so we have drawn A to B 1 line. Again we have A to C, we have 2 lines, so we have drawn 2 arcs over here. A to B is again 1 arc, which is already mentioned over here. B to B is 0, B to C is 3, so we draw 3 arcs here in this way, because B to C is 3, or C to B is 3, C to A is 2 already, and C to C is 0. It's just the reverse process of constructing a graph from a matrix. Till now we have done matrix from a graph. Now it is graph from a matrix. This also is very easy to understand. If any doubts, you can always call or email me.